So the question is, how is server computing like Pi? That's the most important question that we have to answer today, and we're going to discuss that now. I used to work for a company that was an automotive company. So the job that we had was we would connect people's vehicles to the cloud. And so we had these cars that would drive around, and every time we needed to know something about the car would send the information that it had for us up to the cloud. Well, how did that work? So let's discuss how that works, and also what does that have to do with servers and Pi? Well, in this car company, we had 7 different regional clouds. So depending on what part of the world you were in, there would be a specific cloud just for you, and the car would connect to whichever one was closest. And so we had those 7 regions, and we would run out of space rather quickly, believe it or not, in each of those regions. So one day I was talking to a friend of mine, and we were working in the specific cloud in the United States that I was working on, and we were pretty much out of servers. So you think about how a rack, can fit 42 different servers on it, and think, how could you possibly run out of space? And then you talk about a company that sells 10 million cars a year, and all of those cars are trying to talk to your servers. Well, pretty soon all your servers are using all of their capacity to handle the requests from these cars, and that's how you end up running out of space. So my friend and I were talking, and he said, I've started using something called Docker. And I said, Docker, what even is that? And my friend's name was John, and John was short servers just like I was. We were on different teams, and we were sitting across the wall from each other talking. And John said, well, just imagine you've got all these servers running. Just imagine that we could efficiently use up these servers, and that each server could have lots of micro operating systems running inside of a single server. And I said, well, isn't that what virtual machines are for? And John said, yeah, that's what virtual machines are for, but this takes it to a whole other level. So let's talk about what John was doing. You had this rack full of servers, and if we take one of these servers and zoom into it, let's look at what that server would look like at a little bit closer glance. So we've zoomed into one of these servers now, and let's see what was going on inside of it. So the first layer, like John and I were talking about, is called a virtual machine. I mean, it's not really the first layer, it's the first layer of abstraction. And of course, each of these virtual machines can run a completely separate operating system. They get assigned their own piece of the memory, CPU, and hard drive. And so it's just a way of separating things out. Well, so you've got those virtual machines allocated, and then you realize that these virtual machines are not being fully utilized. So each of these virtual machines has a large potential for so many CPUs. Say you have, let's say we have 128 CPUs, so that gives each of these 32 CPUs or cores, each of these virtual machines. Well, in our case, at the company I was working at, we had very, very large servers that had about that many cores, and we weren't using them effectively. So we would give, say, this virtual machine to team A, and we'd give this virtual machine to team B, and this to team C, and so on. And then pretty soon, your whole server has been split up and given out to people. So then another person comes along. It's kind of like somebody came for dinner that you weren't expecting and you hadn't really prepared for them. So what do? Do you go back to the other people whose plates you've filled up and ask them to share their food? Do you go cook some more food? Do you tell the person to go away? None of those things seem to really sound good. And so that's very similar to how we feel when we have people ask for server space and we've run out of server space. So let's talk about what John was doing. What John was doing is saying, let's take this virtual machine and let's talk about how we could use that virtual machine a little better. So we're going to split that virtual machine up now into something called a container. And you'll often hear containers used with the word Docker. So Docker is the most popular micro container platform out there, and it is really cool what it can do. So now say we can take these 32 cores, and what if we could make 32 Docker containers? Can you imagine that? And each of those containers could run a completely separated operating system. Well, what would be the advantage of having 32 separate operating systems instead of just having one? The advantage is that they are running separate processes, and so they can be started and stopped and updated independently and treated like completely separate systems. So now, instead of just having one virtual machine with 32 cores, we have 32 tiny little operating systems running, and we can spin those up and down independently as we need to in response to things that happen. Like, say, for example, there was an error on one of these containers. Well, golly, we've got 32 of them. It's not really a big deal if we need to kill one and spin up another one, or I should say shut one down, spin up another one. So that's what Docker can do for us, is it can use the space that we have more efficiently. So John realized that with this technology, he was able to deploy separate systems that he could control from a single command line. He could monitor them all and also shut them down and start them up all from one place, and that would be from the Docker command line. So that's a technology we will be working a lot with over the next few weeks, is containerization. And just to review, we start off with a server sitting on a rack somewhere. We slice that server up into virtual machines, and then on each of those virtual machines we run a Docker container, and each of those Docker containers can run a separate operating system.